was taken out to this site in the middle of the desert. I had no idea what awaited me. And then I saw them. And I just started crying.
These trackways in the Arabian desert are footprints in time. They were made 7 million years ago by prehistoric elephants. They take us back to a bygone world and its vanished creatures. How did elephants from so long ago give rise to the magnificent animals we know today? How did any of the animals in this African landscape become what they are? For generations, it was a mystery. Now scientists are revealing the answers, piecing together an epic story. This film unlocks the evolution of 4 of the world's most spectacular creatures: crocodiles, birds, whales, and elephants. Like every animal alive today, they have a deep time history, a lineage full of twists and turns, shaped by strange ancestors from long ago. Bizarre ancient crocs.
This thing was built like a greyhound.
Feathered dinosaurs.
Dinosaurs never went extinct. In fact, birds are dinosaurs.
A whale ancestor that lived on land.
It more looks like a dog with a long snout.
It's a story millions of years in the making, of lost creatures rediscovered and the surprising lessons of deep time. At the Museum of Natural History in Paris, one of the birthplaces of paleontology, they have been assembling the skeletons of prehistoric animals for over 200 years. They now have one of the few complete reconstructions of the extraordinary whale ancestor, Pakicetus.
You see it's a quadrupedal animal with higher forelimb and hind limbs. It means that this animal was definitely partly terrestrial. And obviously it's quite a strange animal, very small, doesn't weigh looking at all. It more looks like a dog with a long snout.
Pakicetus is one of the strangest surprises of evolution. A whale ancestor that looks like a small wolf with webbed feet for swimming.
The key thing about it is it has elongated finger and toe bones, so clearly it's already semi-aquatic.
Pakicetus was a creature of the shoreline, hunting for fish and perhaps other small animals in the shallows.
And we think that it was using its longer snout to probe for aquatic prey in the water, and so it was feeding in the water, while almost certainly going out on land to breed and have their young.
Once they adapted to life in the shallows, it took 10 million years for the descendants of Pakicetus to become fully aquatic. Why did it take so long? Because to live underwater, they had to change. It is one of the most remarkable stories of total physical transformation in the annals of evolution.
After Pakicetus, whales take about 10 to 12 million years to evolve into fully aquatic forms. And during that time, their hind limbs tend to get smaller, their skulls tend to get longer, and the nares, which is the hole in the skull where the nose is, moves up the skull. In addition, their forelimbs tend to turn into flippers, and they get more vertebrae in their back, which makes their bodies longer.
But there was still one great transformation to take place in whales: baleen feeding.
So near the base of the whale family tree, there's this major split into the two groups that we have today. We have toothed whales, and then we have baleen whales that actually lose their teeth entirely, and they grow what are called baleen plates. They're made of keratin, so they're actually more like hair or fingernails. And these whales use it to filter their food, so they'll take big gulps of water, and they'll actually filter their prey, little tiny microscopic organisms, out of that water using the baleen plates.
The split into toothed whales like orcas and dolphins, and baleen whales like blue whales and humpbacks happened about 30 million years ago. The toothed whales remained, like their ancient ancestors, predators living mostly in coastal waters. There they could feed on fish, or like some of the orcas, seals and baby sea lions. The baleen feeders underwent a much greater transformation. With a radically new way of filter feeding, they moved into the deep oceans and became huge. Why? For a long time, the massive size of some baleen whales was a puzzle. But it turns out that in the ocean, great size is an advantage.
If you look at the energy budget of these animals, they use fewer calories per unit body mass when you get bigger. And so they're more efficient when they're huge. They're also more efficient when they move, when they swim at large body size. So there's advantages to being large in the ocean.
The huge size of baleen whales is also linked to one of the last great planetary transformations.
Argentina and South America become completely separate from Antarctica, and that changes the currents in the ocean system, and it seems to really have a profound impact on what whales are doing.
The cold current that began to circle Antarctica led to a vast upsurge in the krill population that baleen whales feed on. With large amounts of food and the efficient baleen filter feeding system, there was simply nothing to stop baleen whales from becoming huge. Along with baleen, whales have developed sophisticated fishing behaviors to trap their prey. Humpbacks rely on the help of gulls.
And what's happening is the diving birds are forcing the herring together that form a huge ball that gives the gulls at the surface a chance to propel themselves down and try to grab a herring. And then somehow the humpbacks know that there's a concentration of feed there. And they come with their huge mouths, gulp it down, get rid of the salt water through their baleen, and swallow.
Jackie has been working with the humpback whale population off northern Vancouver Island for almost 20 years. Jackie's work has led her to marvel at the delicate web of relationships linking humpbacks to every aspect of the marine ecosystem.
It's perfection. It's been going on longer than we can understand. Knowing whales keeps me in a state of humility and mystery, which I think is how a human life is well lived. It makes me feel connected. It makes me feel appropriately small in the presence of giants.
Over millions of years, whales grew huge as they explored the seas. But another mammal grew huge as it explored the Earth, evolving its own remarkable tools for life on land. For millennia, these stately creatures have patrolled the African savannas, transforming the land as they go.
We're driving along tracks that the elephants have made. They've been walking on these trails probably for hundreds of years. They create paths that they then use for generations. Elephants are such extraordinary animals. The more we learn about them, the more we realize that we actually are only just scratching the surface. Every new discoveries emerge that elephants can understand things that we couldn't have dreamed possible. And I think we'll never uncover their secrets.
Scientists have shown that elephants communicate through calls, touch, and even low-frequency vibrations, which can travel underground for miles. But there's still a lot that they don't fully understand.
It would be amazing if we could actually uncover what it is that they know. I really think that we are blundering about right now because we don't even have the tools to measure how they communicate.
And Paula is certain that along with their ability to talk to each other, they experience many of the same emotions we feel: grief, anger, and empathy. She senses a mysterious inner life.
When you sit with them for hours, this like wealth of sensations just keep coming and coming and coming, and it just seems to be endless. I feel like I can really sense what is going on with those elephants. And the longer I spend with elephants, the more I feel in tune with them.
As much as she admires them, Paula is keenly aware that elephants today are in trouble.
There used to be dozens of species of elephants, and now there are just 3. And if we're not careful, we will lose them as well, and that will be the end of the lineage of elephants.
Could the ancient lineage of elephants really be coming to an end? How did these magnificent animals go from myriad species to just 3 today? And how did the ancient histories of humans and elephants become so intertwined? As with every lineage, it's a story that begins in deep time. A story told by fossils, most of them found in the birthplace of elephants, Africa. The deep origins of elephants lie in the Turkana Basin in northern Kenya. In a place called Buluk, scientists are finding fossils that point to a magnificent age of elephants. The deep origins of elephants lie in the Turkana Basin in northern Kenya. In a place called Buluk, scientists are finding fossils that point to a magnificent age of elephants.
This is from the right side of the jaw. It's certainly
Fossils are the messengers of the past. I believe that. I think that we as paleontologists are trying to be the interpreters of the messengers from the past. They give you the opportunity to see the kind of incredible journey that elephants had to make to become elephants. It took 60 million years to make an elephant.
Today, Bullock is one of the hottest, driest places on Earth. But 17 million years ago, it was a lush forest with rivers and wetlands.
It's a very wet climate. It's a very equable climate, very warm climate. It's a great place to be a browser. It's a great place to go out and look for vegetation. Great place to go get a salad. Africa in the early Miocene.
How can scientists reconstruct those vanished environments? It turns out ancient landscapes leave traces just like ancient animals do.
We often find fossil wood and fossil seeds, so that's telling us something about the environment. And the red sediments around us are ancient soils. They're actually ancient floodplain deposits. So the animals would have been living out on these floodplains in these forested areas. We're trying to reconstruct the whole environment that these animals were living in. If you go in and just pick up the bones, it's like taking the chocolate chips out of the cookies. So we work with geologists and climate scientists and isotope specialists and all kinds of people, geochemists.
The painstaking work of Ellen and her colleagues is allowing them to reconstruct the whole vanished world of ancient Bullock.
So if you were to be transported back to the early Miocene of Bullock 17 million years ago, it would have been a mature meandering river system and a woodland, and there would have been a whole host of different kinds of elephants. So you would have had the dinotheres. They're very, very primitive. They're about a third or a half the size of a modern elephant, and they would have been kind of snuffling along the riverbanks because they seem to really like a closed canopy forest and a wet environment. But at the same time, you have the ammoebelodonts, the shovel tuskers. The lower incisors are these big, long, shovel-like tusks, so they would have used them to scoop up their dinner.
As scientists excavate, they are astonished by the diversity of strange beasts they are discovering. Ancient Bullock was a sort of Jurassic Park of elephants.
Imagine I'm taking you on a safari, but a safari back in time. You'll be confronted with these magical creatures, a slice of Africa that is now gone. You'd be confronted here with amazing herds of elephants. It'll be mind-blowing to confront this scene. I think the Miocene 16 million years ago at Bullock, that would have been the center of the empire of the age of the elephants.
The ancient elephants here bear witness to a glorious flowering of the elephant lineage about 17 million years ago. But what were their origins? And how did they come by their magnificent tusks and trunks? For decades, the earliest origins of the elephant lineage were a mystery. But then, in the 1990s, a French paleontologist and his team were excavating in an abandoned phosphate mine in Morocco. In layers dating to 56 million years ago, he came across fossil remains of a mysterious animal about the size of a small dog. He called it Phosphatherium. Later, he came across fragments of the jaws and teeth of an older, even smaller creature. This one was no bigger than a rabbit. As he puzzled over both fossils, he noticed something very strange. Their teeth seemed to be miniature replicas of an elephant's teeth. The more he looked, the more certain he became. They must be ancestral elephants, the oldest ever discovered. It was an astonishing conclusion. The oldest elephant ancestor was the size of a rabbit.
Et c'était extraordinaire parce qu'en fait, les fossiles...
It's really amazing. The fossils we found reveal the origins of proboscidean evolution, which used to be totally unknown.
I give a lot of credit to my colleague Emmanuel Gerbrand because it's like a detective story. It's a real puzzler to figure out what they are. And he found these things and he started looking at their teeth and he realized they had some subtle features on their molars, the arrangement of the cusps on their molars, that said, I'm a proboscidean.
Finally, scientists could see the very beginnings of the elephant evolutionary tree.
Parmi les caractères qui évoluent progressivement chez tous ces proboscidiens primitifs,
The key trait is the slow development of incisors at the front of the skull.
commencent à être un peu
They are already starting to become enlarged in Phosphotherium.
schémoériterium,
Those incisors just keep growing through all the stages of elephant evolution, right up to mammoths and modern elephants.
As incisors became tusks, they took on the functions they have in elephants today.
They're used for acquiring food, for knocking down plants so you can reach food. They're used for social display. Tusks are the defining features of elephants, and it's like their behavior is tied up in having these tusks.
And as tusks grew, they propelled the evolution of the trunks that would become the hallmark of all later elephants.
So I think once you start to get tusks, then trunks follow that. It is important because they have to have something to get past the tusks in order to reach the food in their environment.
As trunks grew, they slowly became the amazingly sensitive organ of touch and smell they are in modern elephants.
Trunks are made up of something like 72,000 tiny muscle fibers, so they're highly complex, and they can move them around the way that you can move your hand around playing the piano. Elephants have tremendous control over that trunk. It's not just flopping around and sucking up water. They can really be very gentle. They can pick a penny up off the ground with their trunk. Those trunks get a big workout.
Tusks, trunks, and great size were obviously successful elephant adaptations to their forest environment. But they didn't just help elephants respond to their environment, they gave them the capacity to change it too.
So I think of all the species that we know of, apart from humans, the only other mammals that we know have the capacity to be able to alter the natural ecosystems they live in a short time in a very big way would be the elephants.
Proboscideans are big animals, and you can imagine any big animal going through a landscape is knocking down trees, moving vegetation out of the way, creating paths.
For that, Bill believes we humans owe them a debt of gratitude. He thinks elephants helped create the perfect conditions for a certain group of apes, millions of years later, to come down out of the trees and begin to explore the savannas. Those were our ancestors, the Australopithecines. The famous early human Lucy was discovered not far from Baluk. Bill is convinced that she and our other early human ancestors flourished in a landscape that had been unintentionally prepared for them by elephants.
This idea of elephants opening things up and creating the conditions of success for early hominins might not be an exaggeration to say that we might not be here without elephants.
And just like our ancestors, elephants did not stay put. After millions of years in Africa, they started to leave.
Proboscideans leave Africa multiple times. Different groups leave at different times. The first major foray out of Africa is around 18 million years, and they make it all the way to Japan within a period of about 1 million years after getting out of Africa.
Until recently, all we knew of those ancient elephant species that left Africa was from a few fossil bones. But then, a dramatically different kind of discovery brought them to life. In the deserts of Abu Dhabi, scientists discovered not bones, but footprints. They were made by ancient elephants, a vivid record of their great migration out of Africa.
It's phenomenal because when you're actually on the landscape, it seems like the elephants just passed there yesterday. But we know, geologically speaking, that's impossible. These are very, very old sediments. So it was almost an afterthought to image the tracks from the air. And then we went back to the hotel that night and we started to put the imagery together. As we realized what we had, our jaws dropped.
What they saw was the footprints of an entire herd of ancient elephants on the move. A snapshot in time of elephant behavior 7 million years ago. In the deserts of Abu Dhabi, scientists discovered not bones, but footprints. They were made by ancient elephants, a vivid record of their great migration out of Africa.
It's phenomenal because when you're actually on the landscape, it seems like the elephants just passed there yesterday. But we know, geologically speaking, that's impossible. These are very, very old sediments. So it was almost an afterthought to image the tracks from the air. And then we went back to the hotel that night and we started to put the imagery together. As we realized what we had, our jaws dropped.
What they saw was the footprints of an entire herd of ancient elephants on the move. A snapshot in time of elephant behavior 7 million years ago. Back then, this desert was a lush savanna. The muddy ground after a rainfall captured their footprints perfectly, all made by one of the strangest of elephant relatives.
It's probably 10 minutes in the lives of these individuals, this herd that walked across the landscape, and those 10 minutes are forever preserved in these rocks for us to see.
And in that 10-minute snapshot, Faisal can see all the dynamics of the herd, the adults and calves, a single bull male, and a number of females.
Yeah, so it's a minimum of 13 individuals, actually. You're walking along, and here was a large individual. There was probably the matriarch. They slow down, they speed up a little. There was a smaller guy. He's on the edge, so we're clearly not too worried about any predators coming along on this landscape. And then perhaps just the day before or the day after, we've had the large bull who also crossed this landscape.
Not long after Faisal and his team made their discovery, they took Bill Sanders to see it.
I had no idea what awaited me. And then I saw them. All the footprints of an entire herd going on for about 260 meters. And you can see baby footprints, juvenile footprints, female footprints, and then one great track of a big bull male that must have come along later and crossed that track and sort of checking out the herd. We rarely get that opportunity. I work on elephants, I love elephants, and I'm seeing their behavior crystallize in time all the way back to the very beginnings of elephants. And I just started crying. And my colleagues all sort of applauded, and they realized I was not crying out of sadness. I was crying because I was ecstatic.
Like skilled trackers, the scientists could read the ancient footprints and reconstruct a remarkably detailed picture of that day 7 million years ago.
we could estimate the actual size of these individuals based on stride lengths of modern elephants, where their weights are known and their stride lengths are known. And their estimated weights go from a few hundred kilos for the small one up to 5,000 kilos or so for the largest in the group, and possibly 6,000 or so for the solitary individual that was walking at that site.
That makes them as big as any bull elephant today. From fossils found nearby, we know that they were magnificent animals, four-tusked beasts called stegotetrabelodons.
And here you are, you're on this landscape, and you can imagine them having just been here, like it was yesterday.
Over generations, their ancestors made the journey from Africa, thousands of miles away.
They're extinct, they're long gone, and they haven't just left us their bones and teeth. This is an imprint of their society.
The discoveries in Abu Dhabi show that by 7 million years ago, the social behavior of elephants had already evolved. Their close family bonds have been a key to the success of elephants for generations. Even though stegotetrabelodons disappeared a few million years ago, their descendants and other elephant species soon populated much of the globe. Some, like the mammoths, adapted to the cold of Siberia and North America. Others, like the gomphotheres, headed for the warmer climes of Southern Asia and Central America. It had taken 60 million years, but the elephant lineage had become one of the most successful on the planet. Just 50,000 years ago, elephant species were on all continents except Australia, Antarctica, and South America. So what happened to them all?
A long debate among my colleagues in my field has been, what are the agencies for the extinction of the elephants that we see, for example, mammoths and mastodons?
One hypothesis is climate change. At the end of the last ice age, 10,000 years ago, the world warmed. The cold-adapted elephants of Siberia and North America just couldn't deal with it.
In the northern hemisphere, in northern latitudes, you have all this glaciation, and these changes are happening very, very rapidly.
But for millions of years, the mammoths and mastodons managed to weather similar climate changes. What was different about the warming at the end of the last ice age? Bill believes it was our own ancestors who tipped the balance.
So we see the great sites in Eurasia where indigenous peoples like 10,000 years ago and 50,000 years ago and 60,000 years ago were slaughtering these elephants in great numbers. There is a tremendous predation pressure, and imagine if you've got predation pressure hitting you on one side, and now you've got this climate change and what it does to the landscape, what it does to the plants and the available resources.
By 4,000 years ago, the world was left with just the African, Asian, and forest elephants we know today. And now these are under threat as well. This time, it has nothing to do with the end of an ice age. Just us. In 1800, there were an estimated 25 million elephants. Today, there are less than 1 million, and the number is falling fast thanks to habitat loss and the relentless slaughter of elephants for ivory.
Poaching now is very mechanized, it's industrial.
In some places, we're losing 1,000 elephants in a month. It's being done with not just weapons, but with aircraft, trains, and trucks and ships to move the ivory out of Africa very quickly.
The tusks that helped elephants survive for millions of years have become a liability. It's a new kind of evolutionary pressure, human-generated. And in Africa, it's causing elephants to change almost overnight.
Over the millennia, elephants have evolved to have these huge tusks because the most successful elephants are the ones that had the biggest tusks. But over the last few hundred years, as human beings have been killing elephants for those tusks, so there are some populations of elephants who have very small tusks because poachers are selectively removing elephants with big tusks. And so the only females that get to breed are the ones which have very small tusks. And so you increasingly see tusklessness in some of these elephant populations. It would be such a tragedy if these magnificent animals lost the one thing that makes them, so unique, their tusks.
Even as they adapt, elephants are at risk. Like so many other creatures, they now face a new era of extinction. Everywhere, the natural world is being transformed. Our own lineage has become the planet's dominant evolutionary force, shaping the web of life that exists all around us. This one recently arrived species is now the worldwide presence to which all others must adapt. Our impact is so huge that our era has been given its own name, the Anthropocene, the age of humans. It has seen the extinction rate among natural species soar to hundreds of times what it was before our arrival. As scientists race to chart the planetary changes, they can look back at lessons from deep time. They're observing many of the things that happened in earlier extinctions. Rising CO2 levels leading to acidification of the oceans and rapid climate change. Habitat destruction. Many believe we are witnessing our planet's 6th mass extinction, but the first one caused by a single species. Like others, it will reset the evolutionary clock. We just don't know how.
Today, when we live in a world where human populations are gradually changing the face of the globe by turning natural environments into artificial environments, by pollution and many other ways of interfering with natural systems, we are very much confronted with the question of evolution and extinction. You can't have evolution without extinction, but extinction really complicates our efforts to get the big picture.
We now know that mass extinctions are an engine of evolution, clearing out environments, making room for new species to evolve. But in the past, they have usually taken millions of years. This one is happening fast, in a matter of generations. Viewed through the lens of deep time, that is a nanosecond. Too fast for many living things to adapt. But maybe not too fast for us to make a difference. Crocs have lived on Earth for almost 230 million years. They've survived cataclysmic extinction events. But today, 5 of the 14 crocodile species are critically endangered.
Most of the living crocodilians were on the verge of extinction by the 1970s. We were on the verge of losing all of them when we put in place protection.
Protections have helped. In Australia, both fresh and saltwater crocs have rebounded thanks to strong steps like restrictions on hunting. But what about the other great survivors of deep history? 10,000 species of birds still cover the globe. Some have adapted to cities where they live beside us in seeming harmony. But that's not the whole story.
We are hugely impacting bird evolution. This is in habitat loss, consumption or killing, poisons, the use of toxins in our environment.
With 40% of bird species in decline, there's reason to worry, but also reason to hope. We managed to turn things around for iconic species like the bald eagle and California condor. And innovative programs show that more is possible. In 1974, only 4 Mauritius kestrels were left in the wild. Today, there are 100 times as many, thanks to predator control and captive breeding. Ocean creatures need protection too. It took 50 million years for whales to become the wondrous giants of the deep we know today. But in just 2 centuries, industrial whaling brought many of them to the brink of extinction. In the 20th century alone, almost 3 million whales were slaughtered.
It's unthinkable now that we exploited whales to the extent of, in the case of humpbacks, driving down their population to 10% of what they were globally. They were almost pushed over the edge. We only stopped whaling on northern Vancouver Island in 1967. Humpbacks we stopped in 1965. So we thought of them so very differently. We saw them as a resource. But with humpbacks, we have a second chance.
While some whales are critically endangered, whaling bans have made a difference. Humpbacks have rebounded. And blue whale populations, which fell to just 1,500, seem to be slowly increasing.
One of the many things that the whales do is they remind us how connected we are and of our capacity for change.
Around the planet, others are heeding that reminder, committing themselves to protect endangered animals and places. In Kenya, Paula Kahumbu admires one of the last true giants left on Earth, a tusker named Tolstoy.
I feel very humbled to be able to meet Tolstoy. He is a giant of giants. He's not just a big tusker, he's a super tusker. There are very, very few elephants of that size with tusks of that length left in the world. You know, when you're with Tolstoy, it's one of the biggest rushes you get is that I'm alive, right? You just feel this sense of life. It gives you goosebumps just to know that this elephant is aware of your presence and you're tiny and he's huge. It's beautiful. It's just the most incredible experience.
To know that Tolstoy is the product of an evolutionary journey that has been going on for eons only makes him more precious. And Tolstoy is not alone. Crocodiles and birds, whales and elephants are just 4 life forms among millions. The tree of life is vast, encompassing everything that has ever lived. What will its branches look like after the age of humans? The answer is up to us.